All right. Hi, everyone. Welcome back from lunch. Are you okay? Did you have a good lunch? Yeah? Are you not falling asleep from the food coma, right? We're good? Okay, perfect. So we have a great talk coming up here. We are all really into Swift these days, right? But there are so many libraries, tools that we have. We might have old code that is using other languages like Objective-C. We might be using libraries from C++ or even C. And there's so many things out there. So the question is how to make all these things play well together. And who better to talk about this than someone who has dealt with this a lot? She's a developer at Spotify. I used to work with her, actually. We used to be teammates back in the day. And Spotify obviously uses a lot of C++ for their shared code. So she's going to tell you a lot of great stories on how to make sure that all these languages play well together. So please give a very, very warm welcome to Cecilia Humlelu.
Yes, and me and Jose were not only teammates, we were also drinking buddies back in Spotify. And I still remember that I was drinking Strongbow, and he was very impressed by that. I didn't ask why, but maybe I'll ask afterwards. And I arrived here yesterday. And when I arrived here yesterday afternoon, I was so mind blown by this city. It's so beautiful, and I was really, really happy to be here. And I even forgot what I was going to talk about. But since now we're here, and I'm going to focus the 40 minutes in sharing the knowledge of how to use C, C++, and Objective-C libraries in Swift applications. So, click. Doesn't work. Right. Oh, wow. So it's a lot of delay. I see. Right. So imagine that you're building a shopping application and in Swift, and you would like to use machine learning to see how users do their shoppings in your app. And since the core ML cannot provide us with what we want, so we might need to Google a little bit. So what I would do is Google machine learning libraries and click on the first match. So slow. All right. It's okay. We have some tech difficulties here. So we'll try to not use this one then. And as you can see, that most of them are in the list that are listed in the GitHub. Most of them are in C++ and Python, and none of them in Swift. So what do? Either we use one of them, or we try to find some Swift libraries. And unfortunately, after some digging, there are not any good Swift machine learning libraries. And the same thing would happen to audio processing, video encryption, image processing. Those kind of libraries, they are written a long time ago, and they are in non-Swift. And usually, in this situation, what I would do is either I think about if I should give up, not use machine learnings, or I try to add support for it. But then I think we developers, we never give up, right? So we add support for C, C++, and Objective-C in Swift. And in fact, in my day-to-day work, the Spotify application that includes C, C++, Objective-C, and Swift. So Spotify is not only application that has multiple language support. I think Google, Facebook, Airbnb, Line, and etc. You can name them. And back in the days, so this is how we have added support for non-Swift languages. Back in the days when Spotify doesn't have Swift, so C and C++ are wrapped into Objective-C to be used in Objective-C code. Today, we are building Swift on top of it. So does it still make sense that we still wrap C, C++ with an Objective-C API to be used in Objective-C and Swift? I have some doubt about it, so I did some research, and I would like to share it with you. So When Swift was invented 5 years ago, it was built to support a large amount of Cocoa and Objective-C code. So the communication between Objective-C and Swift are very straightforward today. And Swift also add direct interoperability with C. So we don't need to go through Objective-C for C to be used in Swift. C++, however, can't talk to Swift directly and needs some middle stage. For example, Objective-C. If we're using Objective-C, then we're using Objective-C++, which compiles both C++ and Objective-C code within one compiler. If we're using C, we are possibly going to make a C-only API to be used by Swift. So this is fantastic, isn't it? Everything is connected, which means we can do this. We can add support of C, C++, and Objective-C libraries in Swift applications. And how do we do that? We just need to do two things. Firstly, add the dependencies, because they're libraries, they're third parties, and we're going to write a really nice and a clean wrappers for it. So let's start by the first one, Objective-C. So to demonstrate, I created a vanilla Objective-C project in Objective-C, and I'm going to add it into the Swift application. So when we are using the third parties in Objective-C, we have access to either the entire source code or the framework. And the setup is similar. So and also to avoid I've tried to avoid using third-party management tools so we can focus on original setups. So I'm not using the Cocoa pods and so on. So that's why I'm dragging the project or the framework in. And we will link the libraries in the settings by adding vanilla Objective-C.framework to it. And to use it, import a module, create an instance class, and call a function that's inside the class, and create a random string function. So this is really straightforward, and I believe a lot of you have done that. So let's continue with something more exciting. C++. So if you remember it correctly, that C++ cannot talk to Swift directly. So now I have a demo library called basic cpplib. For it to be used, we need some manual middle stage. For example, Objective-C. So I created another project called Simple CPP Wrapper that would include Objective-C framework. And we do the same thing. We link the frameworks and libraries in the Swift framework by adding lib basic cpp lib.a. And before we start to code anything in Objective-C, first we need to do is to rename the simple CPP wrapper class, that class.m file to .mm file. Because this will enable both C++ and Objective-C to be compiled by Objective-C++ compiler. And then we just write an Objective-C function, because that function is going to be used in Swift. And inside that Objective-C function, we're going to call the C++ function. And the code gets a little bit complicated. I will explain this later. But for now, this is just a skeleton. And then we just do what I explained earlier. That we link the frameworks in the link the Objective-C frameworks in the Swift application. Import a module, call the function, and now C++ code is usable in Swift. The last one is either a piece of cake, or it can be even more complicated. So we will see, right? So most of the time when we're dealing with C libraries, it's static lib. So I created a static lib called pure C. And now I link the PRC in the Swift application by adding libprc.a. The problem is, compared to frameworks, the libraries doesn't have interfaces. And Swift applications doesn't read the headers automatically. So we have a problem. Swift cannot see the C headers. Swift, though, however, use modules. And in modules, we can specify headers. So let's create a module. And in fact, to create a module is really, really simple. We just need to go to the project and create a folder. And the name of the folder is the name of the module. And inside the folder, we create a file called module.modulemap. The name needs to be exactly module.modulemap, otherwise it can't be recognized. Then we start to write some code. How about this? So in the curly brackets, we specify the C header, and export star means everything that is included in the submodule will be automatically exported. And the last step is go into the build settings again and specify the Swift include path to the module map directory. And now we can import a module, C wrapper, that's my example wrapper module, and call the function. And that's it. And this is fantastic, isn't it? Because we just imported 3 different languages in one Swift project. And it's something that I think is really, really cool. But I would like to show you something that's even more exciting. Wrappers. So wrappers, I mean the API wrappers, even though the chocolate wrappers are nice too. But firstly, why wrappers? And do we even need wrappers? Well, if you remember this chart correctly, so Object-C translates well to Swift. So in between, we don't really need to do much there. But C++ cannot talk to Swift, so we need a wrapper. And in between, we have C that we can actually work without additional wrappers. But the interface that are generated on the Swift side aren't always developer-friendly, and sometimes we would really like to avoid writing some repetitive code. So to make the interface really clean and nice, and to extract some underlying details away, this is what wrappers are for. And as usual, we start with something simple. Object-C. As I mentioned earlier, there's really no need to write a wrapper for Object-C. But if we're dealing with really old Object-C frameworks, we might want to rename some classes and functions, for example, like using NS Swift names to make it more Swift compatible. C, however, is another story. In C, we have something called pointers. And pointer is just a variable, but instead of pointing to the actual value, it's pointing to the address of the stored value. So in this example, I have a random string function that points to the memory address of the first char in an array. And when this function is translated into Swift, the char pointer becomes unsafe mutable pointer int8. So Swift regards char pointer unsafe. It's because it doesn't know how the C library manages the memories that the pointer references to. And int8 is the Swift equivalent of char. And Swift string has a convenient method to convert unsafe pointer to string. So when we are writing a Swift function, wrapper function, for C, inside the function, we save the random string return value as a variable, which is a pointer, and we send the pointers to the string init function. This is fairly simple, right? But this is not entirely correct. Because with pointers comes memory management. Now we haven't done anything with memory management. So when we are creating pointers in C, we're actually allocating a certain amount of memories, and it requires us to free the memory. Luckily, Swift provides a function for that, so we just need to call variable.deallocate. And now I'm pretty happy with the implementation, so let's move on. And you might have also noticed that the int size here from the C function is translated to int32 in Swift. It's just that Swift is more explicit with int sizes. And what we need to do here is typecast it. So inside the function, when we're sending from the Swift to the translated C function in Swift, we just typecast it to int32. C also has function pointers. So it is a pointer to a function. It's similar to Object-C blocks. And in this example, I have getNextValue, which take an int and returns an int. And the C function pointers can be sent in as a parameter in a C function. So the function foo takes an int start value and the function pointer getNextValue. And when this function is translated into Swift, it becomes the function pointer becomes Swift closure, but with the annotation called at convention C, which means this is a C function pointer. And when we are writing a Swift wrapper function for the C functions, we are taking an int value and we are also taking a Swift closure. And we want to send the Swift closure inside the C closure, C function pointer. And this is fairly straightforward, right? We just take the getNextValue and give it to the C getNextValue. Of course, there's a twist. This wouldn't work. And it can't convert the value of closure type to expected argument types. So this, for me, looks like we haven't done typecasting for closure. Then let's just do it. So create a local function called local closure, which takes an int32 and returns the int32. Inside it, I typecast the input and output value, so that then I will send the local closure into the translate say function. And this is pretty good, I think. But throw me another error. A C function pointer cannot be formed from a local function that captures context. So what does this mean? So it means the local closure is capturing the context getNextValue, which is from the local function's outer scope. Because Swift is type safe and Swift doesn't know how long the C function is going to keep hold to the Swift closure. So Swift compiler just simply doesn't allow it. And what do we do then? We need to find a way for a function pointer that do not capture the context. And we can do that by assigning it to a global variable. And now, if we use a global variable inside the local function, and give the local function to the translate C function, it's not complaining anymore because global variable will always be available and the local function is not capturing the context. And last library, C++. So C++ is an extension of C. Everything we have learned from C is really useful in C++. However, C++ is more advanced because instead of char pointers, C++ has gotten its own strings. So a function like random string in C++ would return std : column string. And to use, when we are wrapping C++ functions in Object-C, and firstly will be saved as a variable, and we use a function called C_string to convert it into C. And any string takes a C string. So as you can see here, the C is a common ground between C++ and Object-C. And C++ also has classes. And here I have an example with a constructor that takes an int version. When we're using the C++ classes in Object-C, we're instantiating instance of point value, and I call it lib. So when instantiating the Object-C classes, we're also instantiating the C++ class by using new. And then we can call the functions that's inside the C++. And when we're deallocating the Object-C classes, we want to manually deallocating the C++ classes by calling another keyword called delete. So macro is part of the preprocessor, and it can be used in C, C++, and Object-C, but not Swift. What do we do usually is we want to convert the macros into functions. And I have a really simple example here is the get next max value will be converted into 3 functions that takes an int, float, and double. We need to specify the type here. But in the real life, we are possibly thinking like, is this function really needed? Because maybe Swift has provided equivalent function we don't need to translate. But also the macro functions in reality is much more complicated than get max. And we're done. We have set up the 3 different languages and we have writing wrappers for them. And we have a lot of experience with dealing with 4 different languages, and we can go and tell people we have a lot of experience with the whole programming thing, right? It's a lot to take in, so let's take a little bit recap. So it is really easy to set up Object-C, and there's no need to write a wrapper unless you really want to. And it's also easy to set up a C, but you might want to spend a certain amount of time to write a nice and clean wrapper for C. And C++ is also easy to set up, but there you need a wrapper. Now that we know the trick to use use C, C++, and Object-C in Swift, we're not limited to Swift-only libraries. And just in case you haven't get enough of this, I have converted this talk into a Medium article, and in case you want to search it in the future. And also all the example code that's used in this talk, I have also open sourced it. If you find this interesting, this is my Twitter account. I will be available after talk to answer questions about my talk. And there are some people who are also asking about if Spotify is using Swift. So anything related to Swift, Spotify, if you're curious about, I'm here as well, I think. Because I think our ex-Spotifyer is maybe not that enthusiastic about answering them anymore. And that's everything from me. Thank you so much.